Thank you guys for coming. And the next 30 minutes will be a short story about Arcane, as Ada mentioned. A Kubernetes native and recently now open sourced streaming framework that we built at Ecco. So with today's sessions, I'm hoping to give you guys a bit of inspiration for the frameworks that we use at Ecco that really helps us keep a fast pace of development going without at the same time generating a big operational burden for us to maintain. I do know that every company is different, but I do hope that some of the tools that I described today will be useful for you to build what we call a low-ops tech stack. But a little side note to begin with on open source, which is something that my team and I really care about. The quote here, I think, is from Tim O'Reilly, who I believe is the guy who actually coined the term open source. So we see quite often how much innovation can come out of small tech teams when you give them a very big mandate. And for me personally, I think open source is not just the result of that, but actually also the seed that will get this going. For my team, building something with Ecco as customer zero, but not the sole customer, is really their biggest inspiration. Knowing that they can build something that gets to live beyond their daily life at Ecco and really scale beyond. So for those of you who don't know Ecco, we are a Danish comfort footwear and leather company. My role in Ecco is to head up our data technology and data management. In general, Ecco is a third-generation family-owned enterprise with a little bit more than 60 years of history, and has in these 60 years grown to cover more than 100 different countries, producing more than 20 million pairs of shoes every year. One exciting thing about working at Ecco is that we actually own our entire supply chain, all the way back to the leather. And in the last few decades, we've kind of expanded on that notion to also cover our technology. So by building in-house technology hubs. And this is where we come in as a data team in Ecco. So back in 2017, the founding family of Ecco decided that if they wanted to be part of this AI and data wave truly, they needed to not only invest in really good data technology, but at the same time, they needed to actually start building really great data technology in-house. And a popular way to get this going is to launch a little small company outside your main company to give it a bit of a startup vibe and protect it a little bit from the more rigorous processes that you have in the big mothership in a company like Ecco. And this is why we launched Ecco Sneaks and Data in 2017, which, as the name kind of suggests a little bit, is a little hidden from the main company, and it's a little secretive. Over the last 7 years, we have branched out to do quite a lot of exciting projects in Ecco Sneaks and Data, and as you can see, Arcane is just one of these branches. But a thing to note on a journey like this is that it's very easy to innovate very quickly in the beginning when you're not yet live at big scale with your technology. But then once you start scaling out to a company like Ecco, then you get bogged down by maintenance of the solutions that you actually put in place. So I'll use that as my anchoring point today to emphasize on how we build our technology and our tech stack to kind of avoid this potential unfortunate fate. So why do we build our own streaming framework? I don't think I need to tell you guys why streaming is great. In the 6 years I've worked with data and AI at Ecco, I don't think I've seen a single strategy deck that doesn't hail streaming as the only way forward. But probably like you guys, I've kind of come to accept that streaming is a lot easier said than done. And you do want to ask yourself exactly why before you throw yourself headlessly into any kind of streaming implementation. But of course, there are good applications, and I'll start by sharing one of ours. When working in a company like Ecco, there's a huge emphasis on data dashboards. And my first impression with this whole real-time thing was it was really just managers who wanted to see their KPIs tick up in real time towards some kind of a bonus target, which I was not a big fan of. Sometimes I would even joke that it was our store managers that just wanted to sit in their lunchroom with a little monitor showing how many people were in the stores, so they didn't have to actually go into the stores to see that. But for us, we had a much more prescriptive use case in mind, and that was where our streaming journey started. When a customer places an order in a supply chain like Ecco's, we get to take a bit of a decision on where we actually want to fulfill this order from. It could be, of course, quite simply from one of our central warehouses, but what if we realized that nearer to the customer, there's a store that had too much stock and needed to kind of get rid of that stock? That could be, for example, because someone had just recently returned an item to that store that was in the meantime restocked. So with sale frequencies like Ecco, that happens quite often. And especially because when people buy shoes online, they tend to buy 2-3 different sizes, and then they can freely return those sizes to a nearby store. And basically by using real-time inventory and sales data, we were able to really improve how we take this decision, both in terms of being able to get that product to the customer faster and cheaper, but also in terms of actually reducing the stockouts we have in our warehouses and our stores. But all of this came with a bit of a flip side, because once you go to real time, you'll realize that real-time integrations are not just an edge case of doing incremental loads of your data. And there's a lot of things that you suddenly need to start keeping in mind when you're doing real-time integrations. And if you don't handle all of these elegantly, you'll end up with something that becomes quite costly, both on dollars spent on your cloud provider, but also on how much time you're actually spending maintaining these solutions. And this is exactly why we built Arcane, to build a framework that serves the purpose that we consider to be a low ops framework. And also because when you work in an internal tech hub like ours with a quote-unquote single customer, you have to kind of accept that the way you grow your headcounts has to be kind of different from how you would do it in, for example, a software as a service company. Where in a software as a service company, you have more or less a single product that you're scaling out to many customers. We have many products we're serving to a single customer. And so we really need to make sure that when we build things fairly quickly and fast and move on to the next thing, that we don't need to leave a massive burden of maintenance behind in order to continue delivering this service. And consequently, we really want to build stuff that basically takes care of itself after we deploy it. And in high-level terms, for us, that means that we want to keep a lean, but at the same time very extensible toolbox with few tools. In our case, basically 3 key tools that I'll go through today, which is Kubernetes, Datadog, and the Arcane.NET framework. And also by operating this toolbox with fewer, but then highly specialized engineers. And finally, by basically keeping all of these services very easily operable and observable through tools such as Datadog. This then in turn for us helps us keep like a virtuous cycle where the ability for our engineers to really highly specialize and learn a lot in their jobs and take ownership of the projects that they built helps attract them as talent where they would otherwise maybe have sought opportunities at a startup or a software company instead. And these guys then, when they're in Ecco, they get to take ownership, present their stuff at conferences like I do today, and basically start gathering a community for us to grow the products beyond Ecco. And with that, I think I'll change gears to talk a little bit about the actual technology that goes into Arcane and in general our tech stacks. So the first step for us to build something that low ops is that it needs to be easy to maintain and operate. And therefore we need to reduce the amount of manual labor that we need to do to operate and maintain the service. And that also means that for a streaming framework, it needs to handle a wide range of the typical challenges you would see in a streaming framework, such as handling back pressure and memory issues, as well as external issues that could be something like the node that's hosting the service that fails, or network issues, or basically just either the source or destination being temporarily offline. Secondly, we wanted to build something that was really easy to get an overview over through observability. And this is really where we chose Datadog as our solution, and we wanted to build something that integrates natively with that Datadog rather than having to build separate user interfaces for people to operate Arcane. And thirdly, we wanted to keep it low ops by basically making it easy to extend without interfering with the ongoing operation. That would be in terms of making it easy to build new stream integrations and deploy them, and also deploy new streams without having to worry about cluster overloads, etc., and without having to find maintenance windows. And finally, I've talked a lot about the cost of manpower to operate it, but obviously we also want to keep low cost on the dollar spent on our cloud providers. And so for us, that really means building something that runs very graciously on spot machines or on different quality of service levels in Kubernetes in order to really optimize how we use our cloud costs. So jumping a little bit into the first thing, making something that's easy to operate. This is really where the modern Kubernetes tech stack really comes in. And when I say the modern Kubernetes tech stack, it's because Kubernetes has for a long time been the go-to provider for maintaining and operating containers. But in the recent years, a lot has happened that really has helped Kubernetes taking off as an extensible tool set. And one of these are the Kubernetes Operator Pattern, which is now central to everything we do at Ecco. And the concept is actually rather simple. The Kubernetes Operator Pattern seeks to replace a human operator in the effort of monitoring the desired state of a given application or service, and basically checking the current state against that desired state, and checking if anything goes wrong. It will follow a set of checklists or procedures in order to try to restore. And at the same time, obviously, it will share all of this with Datadog for human observability. And so for our implementation of a streaming framework, the Arcane operator would be the first thing you would install on your Kubernetes cluster in order to run Arcane as a streaming solution. The Arcane operator is a fully standalone and super lightweight component that runs on your cluster. The Arcane operator then listens on the cluster for something that we call stream modules or stream classes. That is our way of making it easy to extend Arcane. So stream classes is, think of them like a Python package, or in the case of Arcane, it would be a Helm chart that you can install independently from the Arcane operator. The Arcane operator will then see that a new module has been installed and being able to understand that module. And one of these modules could be something open source, such as like pulling changes from a SQL server or a REST API, or it could be something in-house built that you keep privately and don't put on an open repository and basically just in your own Helm repository. And that way, it makes it easy for you to extend Arcane easily. From the user's point of view, they would then basically define what we call stream resources that points to one of these stream classes. And then the Arcane operator would pick up that there's a new stream resource that matches one of these stream classes, and then it will launch the stream accordingly in order to keep this state. This kind of short YAML file would basically be an example of what the desired state of the application would look like. And the actual stream would then be an independent pod that the Arcane operator will monitor. Sorry, this clicker is, yeah. And speaking of the observability also of Arcane, as I mentioned, that is our second pillar for building something that's easy for us to work with. And as I mentioned, Datadog has become our go-to technology for this, foremostly because Datadog is super extensible, easy to build a lot of things on top of it, but it is also super intuitive for the end user to use. It's worth mentioning that Arcane right now ships with 0 user interface or control panel. All of that happens either through Kubernetes or through Datadog. That means for our users, they don't need to learn another tool. For them, it's just a Datadog dashboard that will tell them exactly what's going on, and Kubernetes in order to operate it. And in terms of what we're actually giving to Datadog, so the first part, as I mentioned, is always having the observable state of Arcane through Datadog. That way, you can easily set up monitoring and alerting. We also supply live metrics in terms of the stream rates, so that you can put up something like anomaly detections in order to have your own custom way of monitoring your streaming application. And the same goes for logging. This is maybe more for the developer's point of view most of the time, but we're able to automatically, in a nice manner, stream all logs from the streaming module to Datadog in order to help traceability. And finally, but not least, the application performance monitoring, or APM, in Datadog is a super intuitive tool that makes it very easy for our users to have a look at how much resources is being used on the streams and compare that to the set resources and the quality of service level that you set in Kubernetes for your app. And that's really a good way of keeping your operating cost low, especially when you're using something like spot machines and limited resources on your quality of service levels. And finally, obviously, as you guys probably know, Datadog comes with a lot of out-of-the-box tools that then you can then add on top of your app without needing to write new integrations, which is everything from automation, alerting, service level, so forth. I think for us, that kind of makes for a really nice marriage between the highly advanced and highly, let's say, complex Kubernetes framework, but highly extensible, together with something that's really easy for the end user to work with in terms of Datadog. And in terms of this extensibility that I mentioned, another big part for us, as I said, was to build something that's easy for local teams to extend without having to, let's say, commit to our main Arcane repository. And the way we've gone about this is to use Arca.net as a framework. So while we have Kubernetes, as you can say, our infrastructure base, and we have Datadog as our visual base, Arca.net is really the SDK that helps really build Arcane as a solid engine. So Arca.net is built on, so it's a .NET port of the Arca framework, which is a actor implementation, which gives it a very strong scalability and inherent resilience against a lot of issues. In terms of streaming, Arca.net then comes with what they call Arca.net Streams, which is a reactive streams implementation, which really simplifies building reactive end-to-end awareness inside your streams when you're building in a framework like Arcane. And also comes with very efficient management of something like backpressure and internal buffering. Reactive streams also makes for a really beautiful abstraction that makes it easy for us to abstract away all of the complexities of a streaming framework for the actual implementation of a specific stream. And finally, the Arca.net framework is incredibly CPU efficient and memory is efficient, keeping a very low overhead for streams. And I think that's especially important for something like streaming, where you typically have a range of different entities you're streaming, where some of them might have a very low rows per day, so to say, rate, and some of them might have 1 million rows per second. But yeah, so in terms of giving you an example of how this extensibility works, I've taken a little example. So let's say we have a user who wants to build a streaming implementation of just random numbers that comes at a fixed interval. So we need to build basically 3 things for a Arcane streaming module. We need to build the actual code that delivers the things, in this case, the random numbers, and bake it into a container image. Then we need to build a custom resource definition, which corresponds to what the user can configure for each stream. In this case, we just want a integer that gives a fixed interval between each random number. And then finally, we need to let Arcane know that this specific CRD is related to Arcane by creating what we call a stream class that references this custom resource definition. And that's really all you need to bake in. In terms of the actual code, we've tried to abstract as much as possible. So you basically have this build graph method that you need to implement, where the good thing is, because we're working with CRDs, which are inherently checked by Kubernetes to follow a given structure, we can safely deserialize the actual spec of this configuration of each stream into your code and make it easy, in this case, to take the interval out. And then basically the next 2 lines of code just creates a arca.net source of random integers that comes at a fixed interval. And then you just wrap that in native sources and sinks from the Arcane framework that we built. And in this case, we built 2 very basic ones. We built what we call a schema-free and a schema-bound source and sink that you can do whether you want schema validation or not in your framework. And then finally, we're just matching it with a JSON sink. So the output of the stream would always be in JSON for this case. And that's really how you build all the text to build a streaming module for Arcane. Obviously, you can make it much more advanced if you want to add some more advanced features. And then the final thing that I mentioned is that obviously we want to keep a low operating cost. So at our use cases in Ecco right now, we are streaming a little more than 1,200 entities. So those could be either from APIs or from SQL Server tables or from file storage. The average footprint of every one of these streams is just a little lower than 200 megabytes of RAM, really keeping it highly efficient. But at the same time, due to the CPU efficiency, we can actually get really high peak loads of more than 100,000 rows per second for a single CPU core. But as I said, one of the big things for us is also the fact that we can run this. So in rough numbers, 80% of our stream resources run on spot machines, which has up to 90% of discount with your cloud service provider. So that really, really drives down the cost for us. And then for very specific, let's say, use cases where we want high availability and don't want the risk of a spot machine, we can put it on reserved instances, and we can then top it up with on-demand machines, keeping a very balanced cost perspective. And with that, I think I'll spend a little time showing you how it would look like to set up Arcane. But given that I don't have a keyboard in front of me, I'll make a demo of a demo here by acting like I'm actually typing away. So the first thing you would do is to install the Arcane operator, as I mentioned before. And that is really just a simple Helm chart installation. Once you've installed it, you will see that there's just a single Arcane operator pod running. And already now, you would be able to go into your Datadog dashboard and see that you have this pod running in your pod overview. And you can see the baseline, let's say, memory and CPU consumption is super low. And that's really it to just keep the operator going. The next thing, as I mentioned, is to install a stream module. So in this case, today I will use an open source stream module that we put on our GitHub repository that's free to use. That helps you pull data out at a fixed rate from various kinds of REST APIs. So in this case, I'll install this, and you can see if you take a look at the logs from the Arcane operator, that what happens when you install the streaming module is basically just that the Arcane operator now knows that there are 3 stream classes that it needs to be aware of. These 3 stream classes are what's packed inside the Helm chart, and basically tells Arcane how to pull data out of different kinds of APIs with a combination of fixed authentication and dynamic authentication and paging. Click. Yes, and you can also see if you quickly go into your kubectl and query which CRDs you have, you can see we have these 3 extra CRDs now. And the stream class and stream job templates are what comes out of the operator installation as well. And so part 3 would then be to launch a simple stream. In this case, I'll pull data out of OpenAQ's air quality API. They have a paged API, which has a fixed authentication. And so I'm using a specific implementation inside this streaming module that helps us take data from that. You can see the first thing I'm doing is I'm referencing this module. The next thing I'll do is I'll give the desired annotated state. In this case, I want my stream to be running. You could also have started it in suspended mode if you wanted to just put the resource without necessarily starting the stream. And then there's a bit of specification that comes in the documentation of this module alone. So in this case, there's a bit of setting up how the URL is and also which data storage you're streaming to, in our case, an S3 storage account. And then you basically just apply that. Of course, at a company like Ecco, running 1,200 streams, it's not like we're doing this for every single one of our streams. We would have a massive, what's it called, Terraform repository with a folder where all of these definitions are. But it's just to give you kind of an idea of how it would be put in. As you can see, when you apply this, you will get your stream up and running, and it will immediately start pulling data. And the operator will, from there on, start monitoring this pod for any issues in the future. We can also now go into our S3 storage account, and you'll see that we got 3 folders. In this specific streaming module, we can backfill. So in the implementation I did just before, I would have asked for 2 months of backfill. So that will come into the so-called backfill folder. The live data will then continuously run into the data folder. And in this specific case, I actually also supplied a schema. So if I use something like Spark Structured Streaming, I can pre-read the schema from the schema folder. And if we look at the Datadog, again, the pods overview will now see that we have 2 pods running, and we can kind of see the CPU and memory overhead of running a stream that pulls out a couple of million rows of data from an API, and see it's really quite low. And finally, there you go. We also have a out-of-the-box dashboard that we are building for Arcane to make it a little easier to get a quick overview of how each stream individually is running. But the whole idea of using something like Datadog is that it's also incredibly easy for our end users to build further dashboarding on top of it. And so in summary, basically just deploying Arcane Operator through a Helm chart, deploying a stream module that could be something you worked on internally, or in our case, something that's open source, again, through a Helm chart, and then basically just a single YAML file to define a stream, and that's what you need to get going with Arcane. All of that in the meantime, behind the scenes, you get the nice resilience of the Arca.NET framework. You get the nice lack of needing to maintain a lot of your infrastructure through the Kubernetes Operator Pattern, and you get nice observability through Datadog. And with that, I'll try to wrap up things. I'm running a little out of time here, but yeah, so far, this is our journey. So for this conference, we decided to open source Arcane finally. That has been something on our plans for quite a while. And we're still in the process of open sourcing as many of these stream modules that we've been using internally in Ecco as possible. Moving down the road, we're hoping that some of you guys might be interested in becoming either contributors or users of Arcane to give us more feedback. We also have a couple of exciting additional projects that we want to build on top of Arcane through something like using large language models to help users more fast write these stream definitions, utilizing the fact that YAMLs are both easily verifiable and they're text files, so they're basically very easy to generate. And yeah, then my team will be going around to conferences trying to build up a community. And if Arcane is not really something you're planning on using, but you just watch this for the storyline, I hope that what you could take away is the things that we care about in building our own internal tech team in the low ops fashion, so that you don't end up with people who are tired of maintaining things, through strategies such as open source specifically, which is probably for me the most important, but also really investing in your team, specializing your engineers. That's, I think, for most engineers, some of the most inspiring things to do. And then in terms of the frameworks, if you guys have not used the Kubernetes Operator Pattern or the Kubernetes native framework yet, I would look into it. It's advanced, but it's really powerful. Arca.NET, if you ever write anything in .NET, super, super useful framework that we use to build pretty much everything at this point. And Datadog, I mean, we're at Dash, so I don't think I need to tell you guys that Datadog is great. And with that, just a massive thanks to the team that's built Arcane. It's worth mentioning that it was supposed to be George here, who has been the team lead on our developers, who is supposed to have presented today, but he wasn't able to travel. But if there's any questions also specifically to him, he'll be very happy to connect with you on LinkedIn or through GitHub. And also a massive thanks to Peterbridge, which is the company behind the Arca.NET port. That's really helped us on our open source journey. And then finally to the many data engineers that has acted as our customer zero in Ecco to help weed out some of the small issues we had in the beginning with Arcane. And with that, I'll take questions. I think we have some microphones if there are any questions.
If you have any questions, you can use the mics there. Thanks, Jakob, for the story. I think I love seeing solutions being written on top of Kubernetes. I think the extensibility of Kubernetes makes people doing amazing stuff on that API. Any questions from the audience? Either you can stand up or I can.
I'm just gonna, is this on? Can you hear me? Yeah, okay, cool. One question I just had in regards to some of the process power and the scale. During the demo, one of the, I think it was the second Datadog dashboard, the Arcane dashboard, it didn't really show details about like processing messages, you know, like the content per second kind of thing.
Yeah.
Whatever. What I'm curious about is it set up to be able to just like scale linearly based upon once you know essentially the schema and what you're expecting to then be able to manage that? What's it look like as far as when you get past a certain point and you're scaled up?
So one of the key aspects of going Kubernetes native, and I think for us also what maybe we can do a little bit on not running, for example, on the JVM, is that with the Arcane.NET framework and the actor model in general, it's very easy to write things that are scalable. It's almost inherent that everything you write is scalable in the sense that, for example, in this case where we're running against an API, you actually need to go the other way and make sure you're not pushing the API too far by adding rate limiting. So by nature, if you're giving more CPU, you can basically just give more threads to the system to pull from. So if you're pulling from something like a scalable SQL server, you can really put a pod with 20 cores, and that will be able to do that. And that's also how we build Arcane to make it easy for the end user to actually define this. So again, the streaming module would have all of the handling of the back pressure, the rate limiting if it's an API you're working against. But in terms of the resources, it would really be down to how you then implement it on the actual stream level. And you could give one stream, a burstable up to 20 cores, so that if there's a big load, it can actually handle that. Or you can have something that's really squeezed into let's say 100 megabytes of RAM, and then the framework will also be aware of that.
Any other questions from the audience? I actually have one question, because one of the things that I saw during the demo is that you had the ability of backfilling data. And one of the things that happens with Kubernetes is that any controller, like any operator, will try to respawn a pod if it crashes. And I wonder if that pod that has backfilled all the data and then crashes, what would happen? Like, it would go again throughout the same process of backfilling data?
Yeah, so the Arcane framework would allow the implementation on the module level to control a little bit on how you actually define this process. So in the case of let's say an API backfill, it might be that you can pick it up based on the actual data. So one of the things with Arcane that we've tried to do is not to have this. So there's no database basically behind Arcane. It's really just the destination and the file structure there, along with its current state that it uses as as its only state. And that means that you can basically write it into the module, that it has a look, again, the end-to-end awareness, has a look at the current destination to know if it needs to restart the backfill. What we have done with most of ours is that if it crashes during the backfill, we'll just start over with the backfill. So just to keep things simple. But you could, in theory, write with the Arcane framework, write something that's even more aware of where it, let's say, ended up. You could also do it in terms of annotations on your pod, or not on your pod, on your resource.
Good. Any final question? Okay, thanks a lot, Jakob.
Thank you.